In this video, we're going to make a bulb light up. We're going to need a 9-volt battery, a 25 ohm resistor, and a bulb. This is the circuit we'll be making today. The electricity flows from the positive side of the battery, through the wire and into the bulb, and afterwards into the resistor and back into the negative side of the battery. The order of the resistor and the bulb does not matter, as long as they are in series with each other. At the moment, the circuit is open right here, so the current cannot flow through. But if I connect these two endpoints and complete the circuit, the current does flow through and lights up the bulb. This is how switches work. We have built the circuit according to the schematic. The positive end of the battery connects into the bulb, the other end of the bulb connects to one end of the resistor, and the other end of the resistor connects to the negative terminal of the battery, just like in the schematic. Right now, the circuit is open, so no current flows through. But if I connect it like this, current flows through the circuit and lights up the LED. If I disconnect it, it turns it off, and if I connect it again, it turns on. Why did we need a resistor, and how do we choose the value of it? Well, on the bulb, it has a rating, and it says 2.5 volts and 0.3 amps. But our battery is 9 volts, which means if we connected it directly, it will burn the bulb. So we need a resistor that can take up the rest of the 9 volts, which is 9 minus 2.5, 6.5 volts. Now, we also know that since these two components are in series, the current going through them is the same, 0.3 amps. Now, with this, we can calculate the value of this resistor using a law known as Ohm's law, which is V equals IR. This means the voltage across the resistor, 6.5 volts, is equal to the current across the resistor, 0.3 amps, multiplied by the value of the resistor. If we put this all in, this means that the resistance is equal to the voltage over the current equals 6.5 volts over 0.3 amps, which is 21.67 ohms, or around 22 ohms. Now, you won't find a resistor that is exactly 22 ohms. So you would usually use a resistor that is around 22, like a 20 ohm resistor or a 25 ohm resistor. In our case, we use a 25 ohm resistor. However, because of the tolerance of resistors, this resistor ended up being 22 ohms anyway. In this circuit, the current flows from the positive side to the negative side, and it only goes in this same direction, which is why it is called direct current, or DC. The lights in your household work very similarly to this, except the voltage is much higher, 240 volts. You might be wondering why there isn't any resistor here when there's a resistor here. That's because the lights in your house are designed to withstand 240 volts. The current flows from the plus side to the negative side, and it goes only in one direction. Unlike that, in your household, the current flows from this end to that end, and it switches directions, which is why it is called alternating current, or AC.